Hello, my name is Abdullah Salar, a student of ComSat SPA. I will share a brief insight of our final year project. The title of our project is Life Cycle Assessment of Self-Compacting Concrete Incorporating Steel Mill Scale. Our project supervisor is Dr. Adnan Nawaz. Our group has three members: Abdullah Salar, Muhammad Ayaz Mahmood, and Saadullah Shah. Now let's move on and talk about some background information about our project. As we all know, it is nearly impossible to avoid the use of concrete in construction, and concrete is not cheap. Also, concrete has many harmful effects on the environment. The consumption of concrete is increasing day by day. Mostly river sand is being used as fine aggregate to make concrete, and its extraction causes erosion, which is bad for aquatic life, and it also decreases the capacity of water bodies. So we are going to replace sand on different proportions with a waste material called steel mill scale, or also steel mill sag. Steel mill scale is a waste product which is generated in steel industries while making the steel. So the question arises, why we are using steel mill scale? It is a non-recyclable hazardous material. Most of it is dumped on land or in water. It pollutes the environment and can cause serious diseases. It is a waste product, hence cheap, so we can reduce the construction cost. Its use in concrete will be a good technique to handle waste management. Now, the next question in your mind will be, what is self-compacting concrete? Self-compacting concrete is a concrete mix which has low yield stress, high deformability, good segregation resistance, and moderate viscosity. So it does not require vibration or tamping after pouring, and it is also much less labor intensive. Now let me tell you about life cycle assessment. Life cycle assessment of a material involves extensive environment analysis throughout its lifetime and potential options for environmental improvements. These are our research objectives: to determine the effects of partial and full replacement of sand with steel mill scale on the properties of self-compacting concrete, and to carry out life cycle assessment of self-compacting concrete. Some of socio-economic benefits of our projects are: as steel mill scale is non-recyclable hazardous waste product and it is dumped into water or landfill, which causes pollution. So its use in concrete to some extent will have a good effect on our environment. It is a waste product, so it is more economical than sand or other fine aggregates. So by using this, we will also be making a less costly concrete. Moving on, now let's talk about our methodology. First of all, we procured all of the materials required, which included steel mill scale, natural sand, cement of 10,000 psi strength at 28 days, coarse aggregate, and viscocrete 3110 as super plasticizer. Then we did some trials for self-compacting concrete. The trials were done to achieve a suitable mixing ratio. After getting the desired mix ratio, mix design was generated using a software. Here you can see the mix design. We prepared samples for these 7 mixes. Control mix had 100% sand used as fine aggregate. In second mix, 25% of sand was replaced with steel mill scale. In third mix, its percentage was increased to 40%. Then to 50% in fourth mix. After that, fifth mix, it was increased to 60%. In sixth mix, 75% of aggregate was steel mill scale, and in seventh mix only steel mill scale was used as fine aggregate. We prepared the samples using this design mix, and then they were left for curing. After that, we tested the strength of those samples on 3 days, 7 days, 14 days, and 27 days of curing. We did some other tests too before that. The tests we did are on your screen. We conducted tests on the procured materials, then we did some tests on fresh concrete, and then on hardened concrete. 4 durability tests were also conducted on samples from each mix. Here are the results showing average compressive strength and average tensile strength for each mix. As you can see that the strength increased and the maximum strength was achieved on the third mix where 40% of fine aggregate was steel mill scale. After that strength started decreasing. So that's the best mix to use. These are some of our project outcomes. We will be able to study the effect of steel mill scale on the strength of concrete when it is used in different proportions. And we will be able to make economical or somewhat environment friendly concrete. What we will do about the life cycle assessment of self-compacting concrete. We will use software such as OpenLCA for life cycle assessment of self-compacting concrete. When bulk of steel mill scale is dumped into water, it has bad effects on the aquatic life. Use of steel mill scale in concrete will be a good technique to handle waste management. That's all from our side. Thank you so much for watching. Take care. Have a great day.